Morning students. So video 11 we will continue with parasympathetic nervous system. So last class we have dealt about sympathetic nervous system. Under that we have seen the structure, that is pre-ganglionic fibers, post-ganglionic fibers, and in between ganglion. So how pre joins to the ganglion and what joins the ganglion to the post-ganglionic fibers. Okay, so today we will see parasympathetic nervous system, and we will see how again pre-ganglion connects to ganglion and post-ganglion. Okay, so in sympathetic you have the same structures but it differently connects. Okay, so we will see the variation how it connects in the parasympathetic nervous system. So the pre-ganglionic fibers of parasympathetic nerves, they arise from midbrain, medulla, sacral portion of spinal cord as follows. So there we have seen in sympathetic that it arises from the lateral horn cells of the spinal cord. I hope you remember that. Okay, so here we see that the pre-ganglionic fibers of parasympathetic nervous system arise, or nerve cells arise from cells which are present in midbrain, medulla oblongata and sacral portion of spinal cord as follows. Okay, so we will see step by step how it arises. So from the midbrain, the fibers emerge through oculomotor nerve. So I hope you remember oculomotor nerve. Where did we study? Spinal nerve. Okay, so it is the third nerve, right? Okay, so here we study that midbrain, it is arising from the midbrain and the fibers are coming. Okay, the nerve fibers are coming through the oculomotor nerve. Okay, next you have from the medulla, they emerge through facial, glossopharyngeal and vagus nerve. Okay, so 7th nerve, 10th nerve. Okay, you should remember, that's why you should study. Okay, so one of our trained teacher asked for very good vada and halwa. Okay, remember the first letter. Okay, so now, so from the midbrain it emerges through the oculomotor. From the medulla they emerge from the facial, glossopharyngeal and vagus nerve. Okay, so glosso is for the tongue and pharynx. Okay, so glossopharyngeal and vagus nerve. So medulla, okay, from medulla they emerge from the facial, glossopharyngeal and vagus nerve. Okay, at the sacral portion of spinal cord, they arise from the anterior column of 2nd, 3rd, 4th lumbar segments. Then they pass through anterior roots of the corresponding spinal nerves. So that's why the parasympathetic nerve is called as craniosacral outflow, because there is a connection between the brain, right? That is the midbrain, medulla oblongata, and we see that the sacral portion. So that's why it is called as craniosacral outflow. But in sympathetic it was thoracolumbar outflow. From thorax it goes to the lumbar and then it comes out. So here from the brain, that is the midbrain, medulla oblongata, it comes to the sacrum and then it comes outside. Okay, so from the sacral portion of the spinal cord, if you see, they arise from the anterior column of 2nd, 3rd and 4th of lumbar segments. Okay, so from the sacrum it enters into the lumbar. Okay, that is 2nd, 3rd and 4th lumbar segments. Then they pass through anterior roots of the corresponding spinal nerves. Then they pass on to anterior root of the corresponding spinal nerves. Okay, so all these nerves which have 3 different origins end in ganglion each. So in all these nerves you will see that there are 3 different origin end, okay, in a ganglion each. These parasympathetic ganglia are very near to the structure which these nerves supply. As we have seen, it starts from the sacrum of the spinal cord. Then it arises from the anterior portion of 2nd, 3rd, 4th of lumbar segments. From there it passes through the anterior roots of the corresponding spinal nerves. Okay, so far you have to remember. Okay, so how it comes from midbrain, from where it comes from the medulla oblongata, and from sacral it goes to the lumbar 1, 2, 3, and then from there it goes into the anterior part of the spinal nerves. Okay, Okay, so all these nerves which have different origin. So when you see all these nerves, they are arising from different places. They are coming from different places. Okay, that is why we called it as origin, means starting. Their starting point is different from each other, end in a ganglion each. So they all come from different places and they end in the ganglion. They connect to the ganglion. So these parasympathetic ganglia are very near to the structure which these nerves supply. Okay, so when we see, okay, so after it approaches to the ganglion, these parasympathetic ganglia are very near to the structure which these nerves supply. Okay. So you understood. So after that it will join again into the postganglionic fibers. So these arise from the ganglia and then reach the structures which these nerves supply. Okay. So from there it will go to the organ to which these nerves will get connected. So here mainly in sympathetic nervous system we have seen how it connects through the white ramus, right, to the ganglia, and then to the grey ramus, that is the ganglionic nerve. But here you have nothing. So from the outlet of the anterior root of the spinal cord, it will connect to the ganglion. Then from the ganglion, it will reach to the postganglionic nerve, and from there it will go to the organ wherever the nerves have to supply. Okay, so that will be the effector organ. To whichever organ they are going to supply nerve, it will go to that. Very simple. Okay, next, chemical transmitter. So far we have seen that autonomic nervous system is divided into sympathetic nervous system, parasympathetic nervous system. Then we saw what are the essential, okay, or constituents of this, that is preganglionic nerve, ganglion, postganglionic nerve, effector organ. Then we have seen in detail the structure, how it connects, okay, from preganglion to postganglion, both in sympathetic and parasympathetic nervous system. So now we will see what are the chemical transmitters of autonomic nerves. Okay, so when we talk about parasympathetic system, the transmitter in preganglionic parasympathetic nerve is acetylcholine, which is liberated at the ganglion. Okay, so the transmitter in preganglionic parasympathetic nerve is acetylcholine, which is liberated at the ganglion. So when we say these chemical transmitters, so these are like chemical, which are transmitted by these nerves, which are useful. So the transmitter in preganglionic parasympathetic nerve, what is the transmitter there? What is the chemical that is transmitted is acetylcholine, that is ACH, okay, which is liberated at the ganglion. So this transmitter in preganglionic parasympathetic nerve is ACH, acetylcholine, and this is released, liberated means released at the ganglion. So from preganglionic nerve, this chemical acetylcholine is produced, and from there it is released into the ganglion. So next structure after preganglion is ganglion. So when it is released in the preganglion, automatically it will go into the ganglion. Okay. Next, so you can see a diagram here. So how preganglionic parasympathetic nerve is there and acetylcholine is entering into the ganglion. Okay. Again, second step, what happens? Acetylcholine is a transmitter in postganglionic parasympathetic nerve. So the same only will enter into the parasympathetic nerve. Okay, and it is liberated at the nerve ending. Okay, so it is liberated at the postganglionic parasympathetic nerve ending. So this chemical transmitter is actually produced in preganglionic. It is liberated into the ganglion. From the ganglion, again it enters into the postganglionic parasympathetic nerve. Okay, then you have sympathetic system. So in parasympathetic, the main chemical transmitter is the acetylcholine. Okay, in sympathetic system, similar to preganglionic parasympathetic nerve, acetylcholine is a transmitter in preganglionic sympathetic nerve also. But in postganglionic sympathetic nerves, Non-adrenaline is the transmitter. It is liberated at the postganglionic sympathetic nerve ending. So here in sympathetic, you have two chemical transmitter. So one is same like the parasympathetic, that is the acetylcholine, which is again in the preganglionic nerve, and then it is also reaching to ganglion. But there is another chemical neurotransmitter which is produced by the postganglionic sympathetic nerve, is the noradrenaline. Okay, the spelling mistake is there. It is NORADRENALINE. Okay, noradrenaline. Okay, so when you read that picture, you will understand easily. So in parasympathetic, only acetylcholine, and it is the same for the post ganglionic sympathetic nerve, and then this reaches to the root of the sympathetic nerve, and from there it will be passed on to the effector organ. In sympathetic, you have two hormones, two transmitter, chemical transmitter, that is the preganglionic gives acetylcholine and it goes to the ganglion, and then again in post you have noradrenaline which goes to the effector organ. Okay, next we will see what are the functions of autonomic nervous system and what are the functions of sympathetic nervous system and parasympathetic nervous system. So when we say functions, the functions of sympathetic and parasympathetic nervous system is given in the following table. The mutual antagonist effects of these two systems can be noted. So they both have antagonist action. Okay, so sympathetic nervous system, it helps in the dilatation of the pupil of the eye. So this eye, okay, in the mid, when you see, if you put a torchlight, you have to bring like this and keep, you'll see that it will dilate. Okay, so this dilatation of the pupil bada ho jata hai. Okay, that pupil, when you see with the torchlight, when you're exposed, automatically that the pupil will become big, it will elaborate like this and it will come down once you take off the the light. Okay, so the same thing happens to our pupil when you go to a dark place. Okay, there is no bijli, no current. So when you enter into a dark room, automatically your pupil, to cope up, okay, if you can see anything, automatically it will dilate. Okay, so this dilatation of the pupil of the eye is a function of sympathetic system. Okay, and in parasympathetic it is a constriction. So when it goes, it becomes big, you can say that it is dilatation, and when it comes back to its original position, it is the constriction of pupil. Next is dilatation of bronchi, constriction of bronchi. So bronchi, in the lungs. Okay, so you have the bronchi. Okay, then it is divided into bronchioles. So this dilatation happens because of sympathetic, and constriction happens going back to the normal position. Okay, constriction of bronchi. Next you have constriction of blood vessels and then dilatation of blood vessels. So here in the action of blood vessel, there is a change of action. Okay, so sympathetic system, when we say, there is a constriction of blood vessel, and in parasympathetic it is a dilatation of the blood vessel. Okay, then sympathetic nervous system is having an important role in increasing the heart rate and force of the heart. It increases the heart rate, it increases the force of the heart. So here it decreases the heart rate and force of the heart. Then it decreases in glandular secretion. Okay, and then increase in glandular secretion. So here all the glands secrete, right? So glands, we see that they produce, secretion, hormones. Okay, so there is a decrease. So what causes the decrease? It is the sympathetic nervous system. When there is a increased production of the glandular secretions, it is because of the parasympathetic system. So sweat gland, okay. So sweat gland produces sweat, right. Sebum produces oil. Okay, when there is an excess of these, okay, that is because of the parasympathetic system. Next, the last function, decrease in gastrointestinal motility, increase in gastrointestinal motility. So the sympathetic system makes sure that it increases the gastrointestinal bowel movement, okay, is decreased, and in parasympathetic it is increased. Okay, so learn this tabular column and by heart. Okay, so sympathetic and parasympathetic nervous system. Next, we'll go to adrenergic receptors. So what are these receptors? So these receptors present at the postganglionic sympathetic nerve ending are called adrenergic receptors. So we have seen that the end, so it is beginning is the preganglion, then you have ganglion, then the postganglion. So we see that postganglionic sympathetic nerve endings, they are having adrenergic receptors. So the adrenergic receptors are classified as alpha. So these nerve endings are called as adrenergic receptors. There are two types: alpha receptors, the action on which is excitatory except intestine; then beta receptors, the action on which is inhibitory except heart. These receptors are of great importance in pharmacology. Okay, so when we say alpha, here the action on which excitatory, okay, so it mainly leads to the, except of intestine, all other body gets excited or activated, so that is done by alpha receptors. So the action on which is excitatory except intestine. Okay, so if the intestine starts to have increased activity or excitability, it will lead to diarrhea. Okay, so beta receptors, the action on which is inhibitory. Okay, these beta receptors will inhibit or stop certain action in the body. Okay, so that excites, it increases, alpha receptors increases the action, beta receptor, the action on which is inhibitory. Okay, except heart. So it can stop, but heart, if it stops functioning, what happens? A person will die. So except of heart, other organs in the body is kept in control. So that those are beta receptors. And these receptors are of great importance in pharmacology. What is pharmacology? Study of medicine. Okay, so these receptors play a vital role when the medications are given to patient. Okay, so with this your CNS is over. I have completed the unit. Okay, so far, so in this video we have seen from parasympathetic. So autonomic means parasympathetic, sympathetic. You should write about the structure, and then you should write about the chemical transmitter of autonomic nervous system. Okay, what chemicals transmitter are there in sympathetic and parasympathetic, and then you should talk about the functions of sympathetic, parasympathetic, that is autonomic nervous system. Then we have to talk about the adrenergic receptors. There are two types of receptors, alpha and beta. Alpha will cause excitement in the body except intestine, and beta will causes hindrance or inhibits or it stops, okay, except of heart. So we have done with the central nervous system. I think 11 videos we have seen, starting from the brain. Okay, so central nervous system, it is formed by the brain and spinal cord. We have studied brain completely, spinal cord completely. Then peripheral nervous system, we have studied about cranial nerves 12 pair, spinal nerves 31 pairs, and then autonomic nervous system, okay, which has sympathetic and parasympathetic nervous system. Okay, so I will also be taking one more unit in anatomy. Okay, and that is organs of special senses: eyes, ears, nose, tongue, skin. Okay, and all these are 5 marks question. They are very, very, very important. You should study. They might ask tongue, or they might ask skin, they can ask ear, they can ask eyes. Okay, so one day we will see one structure. With the diagram I will be posting. If any one structure is big, we will do half and half. Okay, so make sure that you draw the diagram well, study all the structures. Okay, so by now I am giving break. Okay, so I will give, today is Saturday, maybe next week 3-4 days I will give you break, so you can prepare CNS properly. Prepare it thoroughly, write the notes. Okay, finish it off, study. Next we will be going, maybe probably Thursday, Friday. Okay, I will be starting with organs of special senses. Okay, till then take care. Any doubt, please keep it posted. Make sure you go through all the videos.